Howdy, mathematicians. Some of you asked some really great questions in yesterday's Ed Puzzle video, and I'd like to address two of them now. One of the questions was, does it matter which denominator you use to divide your bar up first? And the other question was, what happens when you multiply two improper fractions and not one improper fraction? So I'm going to address both of those questions in this video. So here in the problem it says find the product of 5/3 and 9/4. So right away we can see that we have two improper fractions. 5/3 is an improper fraction, and so is 9/4. So the person who asked, what happens when we multiply two improper fractions, or how would we represent that? I'm going to help you do that today. And for the person who asked, does it matter if you start with the denominator of the first improper fraction? Let's see. We're going to try it out. So a lot of you know sometimes I like to start with the second denominator. Let's see if it matters if we start with the first denominator. So we're going to find 5/3 of 9/4, which means we're going to multiply. So the way I will draw my bar first is, since we're going to do the first denominator, I'm going to divide my bar into thirds. So I'm going to create this bar, and dividing it into thirds, I'll use my red. So here I have my thirds. And my numerator tells me that I have 5 of them. So this is really interesting. If I need to represent 5/3, here I have 1/3. Here I have 2/3. Here I have 3/3. Right away, I already know that I need to draw another bar because I haven't even represented my first fraction completely yet. So now I'm going to draw my 5/3. So I had 3/3 up there. Here's 4/3, and here's 5/3. So now I have my 5/3. One thing we need to be very mindful of when we start with an improper fraction is that we are going to take the next denominator, which we know is fourths, right? So we're going to divide each bar into fourths. So let's show that here. So here we go. 1, 2, 3. We draw 3 lines. We get fourths. 1, 2, 3. So the way I always like to think about this is, well, what if I only wanted 1/4 of 5/3? If I only wanted 1/4, it would be both bars. I would group them together. That would be 1/4 of 5/3. And you may be asking, well, Profe, why isn't 1/4 just this first bar? Well, that would be 1/4 of 3/3. But since we need 1/4 of 5/3, we have to draw our box over both bars. So this would be 1/4 of 5/3. Well, do we want 1/4? No, we want 9/4. So let's check it out. Well, here's 2/4. Here's 3/4. Here's 4/4. So right here we have 4/4 of 5/3. And what we know is that 4/4 is equal to 1 whole. And when we multiply anything times 1, we're really just getting itself. So if we did have 4/4 of 5/3, it would still just be 5/3. It's the whole part that we already had. But what we realize now is that we are still going to need more bars because we don't want 4/4, we want 9/4. So we're going to need to recreate again 5/3. So that means again we're going to need 2 more bars. Why? Because 5/3, we need 2 bars to represent that. So again, I draw my thirds. And how do I show 5 of them? 1/3, 2/3, 3/3, 4/3, 5/3. And now I use my other color to show my fourth. So I'm going to break this into 4 parts. And then I break my other bar model into 4 parts. And so let's go back and look at the first one. So here we had 1/4, 2/4, 3/4, 4/4. And now let's look. Here we're going to have, remember, both bars. That's 5/4, 6/4, 7/4, 8/4. Oh my gosh, we're still not done, and we've already used up a whole nother set of bars. What does that mean? we're going to need to draw another set of bars. So here we had 8/4. Between these 4 bars, we have 8/4 represented, which basically means we're multiplying it times 2. But we need 9/4, which means we're going to need another set of 5/3. And I'm going to draw these a little smaller, although if we were going to actually do them, we know we would want them to be the same size. I just ran out of space on here. So here's going to be 1 bar, oops, and then here's going to be my other bar. We're going to divide them into thirds to show that we had 5/3 at first, and I'm going to shade in 5 of them. 1/3, 2/3, 3/3, 4/3, 5/3, and now I need to divide them into fourths again. Okay, so I had 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Now I only need the top part of my next set to show that I need 9/4. And believe it or not, that top part includes the top part of these 3/3 and the top part of these 2/3 over there, which is 5/3 all together. So now here comes the tricky part. I need to figure out how many do I have all together. And what I have all together is whatever has the double coloring. So if we go back and we can see that I had in 1/4, I had 1, 2, 3, 4, 5 that had double coloring. Well, that was just for 1/4. But I have 9/4. So here's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, and over here between this top and this top, I have my 9/4. So if I have 9 groups of 5, that means 45 boxes have been double colored in. Well, so that's my numerator. I know that 45 is my numerator, but remember, how do I figure out my denominator? Well, I'm only going to look at what one box is divided into. And actually, this was another question a lot of you had. Profe, why do we only look at one box? Well, the denominator for any fraction tells us what one whole is divided into. And 1 bar represents 1 whole. Well, let's see. How many boxes did we have in this 1 whole? 1, 2, 3 times 1, 2, 3, 4, which means we had 12 boxes in each whole. Well, we can't leave it as an improper fraction unless it tells us to. So we want to think, how many times does 12 go into 45? I believe the answer is 3, since 12 times 3 is 36. And we want to figure out how many is left over. Would actually be 9/12. And we need to simplify, so we actually have 3 3/4 as our final answer. So friends, I hope I answered some of your questions in this video, and if you have any more, feel free to ask.